Okay, in this video we're going to talk about the fundamental theorem of calculus, and there are actually two parts. Part 1 says if f of x is continuous on a closed interval from a to b and has an antiderivative, then the definite integral of f of x from a to b is equal to f of b minus f of a, where capital F is the antiderivative of lowercase f. Okay, so if you guys remember, this was what we were building up to, which I would call the shortcut method of finding the exact area. So what you always want to start by finding your antiderivative. So remember, we're working backwards. This is where we want to add 1 to the exponent and then divide by that number. Okay, add 1 to the exponent, divide by that number. Now, when you find your antiderivative, that's when you want to drop your integral symbol and your differential, or dx, okay? But we often use this bracket so that we can still represent our limits of integration, because our next step is to plug those in. Now, before I do that, I'm just going to clean this up a little bit. We're going to have x to the 10th plus x to the 6th over 2 from negative 2 to positive 2. Okay, so then we're going to plug in positive 2 minus, and we're going to plug in negative 2. Actually, don't need that fraction bar. Okay, now, these actually end up being the same value, but I hope you can see the f of b minus f of a, okay? These actually both end up working out to 1,056. So in the end, we get 0. Okay, let's look at another example. So in example B, we're evaluating the definite integral of the square root of x from 0 to 4. So remember, anytime you have a radical, you want to convert it to a fractional exponent first, so that we can apply that power rule. Okay, so now we're going to find the antiderivative. So we're going to add 1 to the exponent. So that'll become 3 over 2. We're going to divide by 3 over 2, which is the same as multiplying by 2/3 from 0 to 4. Then we're going to plug in our upper limit, so that'll be 4 to the 3/2, minus, plug in your lower limit, so that's 0 to the 3/2 power. So this will end up equaling 2/3 times 4 to the 3/2 power. Well, remember, that converts back to the square root of 4 cubed. The square root of 4 is 2, and 2 cubed is 8. Then, if we multiply straight across, because that is 8 over 1, we get 16 over 3. Okay, in this example, I wanted to remind you of the fact that there is no product rule or quotient rule for antiderivatives. So if you're ever faced with a product or a quotient, you just have to multiply or divide first. So in our next example, we're just going to have to do the division first, okay? So this will become the definite integral from 4 to 9 of 16 divided by t squared plus t divided by t squared. Okay, so that'll simplify to 16 over t squared plus 1 over t. Okay, now I'm going to antiderive. And actually, I'm going to convert that 16 over t squared to 16 times t to the negative 2 power. Again, so that I can apply that power rule, okay? All right, so I'm going to add 1 to my exponent, divide by that number, which is going to make that negative, plus, and I hope you remember, The antiderivative of 1 over t is the natural log of the absolute value of t. All right. Then we are going to plug in our upper limit. So that'll become negative 16 over 9 plus the natural log of 9, okay, minus, we're going to plug in our lower limit. So we're going to get negative 16 over 4 plus the natural log of 4. The reason I put f of a in parentheses is so I don't forget to distribute that negative, because sometimes that can be an easy mistake to make. So I'm going to go ahead and distribute my negative, but then divide the 16 by 4 and make that plus 4 minus the natural log of 4. And then I'm going to add negative 16 over 9 plus 4. So that'll become negative 16 over 9 plus 36 over 9 plus natural log of 9 minus natural log of 4. So this will become 20 over 9 plus. Now, we can also condense those logarithms using the laws of logarithms. When you're subtracting logarithms, you can condense it into a single log where you divide the values or expressions, okay? From there, that's as much as we can do to simplify it, other than keying it in a calculator and having to round or approximate our final answer, okay? So I would stop there. Okay, then of course I wanted to throw in a trig function, but again, it works the same way. Find the antiderivative of sine of theta, which is negative cosine of theta, from pi over 4 to 3 pi over 4. You plug in your upper limit minus, plug in your lower limit, and then you have to remember that unit circle. Cosine of 3 pi over 4 is negative square root of 2 over 2. Minus cosine of pi over 4 is square root of 2 over 2. Now if I distribute my negative, I'm going to get square root of 2 over 2 plus square root of 2 over 2. I'm adding fractions. I have a common denominator, so I can just add my numerator, put it over my common denominator, but then I can simplify it to just square root of 2. Okay. All right, so that was Fundamental Theorem of Calculus Part 1. Fundamental Theorem of Calculus Part 2, remember, this has to do with what we call the area function. And you can usually recognize it because your upper limit is a variable, okay? So if we evaluate that definite integral using f of b minus f of a, we end up with a function that represents the area from a to whatever x is, okay? Now, if we find the derivative of that area function, so that's what this is showing you, the derivative of a of x just equals f of x. So remember, that's when you're finding the derivative of the antiderivative. So they're going to undo each other, and all you're going to do is replace t with x. The third thing you need to remember is if your upper limit is more than just x, so we're calling it g of x, then when you find that derivative, a prime of x, you are going to substitute t with g of x. So you'll get f of g of x, but then you have to multiply it times the derivative of g of x. So you're using chain rule in that case. All right, let's look at a few examples. All right, in number 1, it says if g of x equals the definite integral from 1 to x of tangent of t dt, find g of 1. Well, remember, g of 1 just means you're replacing x with 1. So your upper limit becomes 1. And then using the properties of definite integrals, we know that that is equal to 0. All right, in part B, we're being asked to find g prime of pi over 4. So we're finding the derivative, okay? So let's find g prime of x first. So remember, all we're doing in that case is replacing t with x. So that just equals tangent of x. And then g prime of pi over 4 means we're replacing x with pi over 4. And then we're just thinking to our unit circle, tangent of pi over 4 is equal to 1. Okay, in number 2, we're going to find a formula for the function represented by the integral. So we're actually using f of b minus f of a for this. It's just our upper limit is x, okay? But we're going to approach it the same way. We're going to find the antiderivative from 2 to x. We're going to plug in our upper limit minus, we're going to plug in our lower limit. So 2 cubed is 8, so we'll get 8 over 3. Minus 2 squared is 4, divided by 2 is 2. And then we'll just calculate that. Okay, so this will become, if I convert the 2 to 6 over 3, and then subtract my numerator, that's going to become minus 2/3. Okay, the next one is cosine of u. So the antiderivative is sine of u from pi over 4 to x. We're going to plug in our upper limit, which is x, minus, plug in your lower limit, which is pi over 4, and then we'll just evaluate that from our unit circle. So sine of pi over 4 is square root of 2 over 2. And we get our final answer, or function. Okay, now in number 3, what I'm showing you here, this is where you're finding the derivative of the antiderivative. So these are super duper easy. All you're doing is replacing t with x. Okay? Now in example B, we are going to start by replacing t with x cubed, but this is technically chain rule. We have to multiply by the derivative of x cubed, which is 3x squared. So this is 3x squared times the tangent of x cubed. These can be super duper easy on the AP exam if you can recognize them. And what makes it easier to recognize them is that you're finding the derivative of the antiderivative, or integral. Okay, the last thing we need to talk about is the substitution method for definite integrals. So this is like chain rule backwards, okay? So you want to use substitution method anytime you have an inside function. So if you look at the first example, x squared plus 1 would be your inside function. So we're going to set that equal to u. We're going to find the derivative of that, which is du. And then we're going to start substituting. So I'm noticing that we have the x and the dx, okay? But we don't have the 2 in front of the x. So this is one of those cases where, okay, we can add it as long as we cancel it. So now everything will match to where we can do our u substitution. But this is going to become 1/2 times the definite integral of 1 over u cubed du. Okay, now we also have to change our limits of integration. So that's where you plug in to u, okay? So when x is 0, u would be 0 squared plus 1, or 1. So our lower limit becomes 1. And then our upper limit is 1 squared plus 1, or 2. And then once you've changed everything from x to u, then you're just doing f of b minus f of a. Okay, so we're going to find our antiderivative And I would think of this as u to the negative 3. So if we add 1, we're going to get negative 2. Divide by negative 2, which is the same as multiplying by negative 1/2 from 1 to 2. So this will become negative 1/4 times, I'm going to plug in my upper limit, minus, I'm going to plug in my lower limit. And if you guys remember, 1 to any power is 1, okay? But 2 to the negative 2, that's going to become 1 over 4, because that'll become 1 over 2 squared, which is 1 over 4, minus 1. Okay, to go any further, we need to find a common denominator. So I would convert the 1 to 4 over 4. And so this will become negative 1/4 times negative 3/4, which in the end becomes 3 over 16. Okay. All right, one more example of u substitution. So here we're going to set u equal to x minus 9 because it is inside the parentheses, or it is raised to the power. We're going to find the derivative, which is going to be 1 times dx. We're going to do our u substitution. So this will become the integral of u to the negative 2/3 du. We need to change our limits of integration, so we're going to plug in 10 for x, and so our lower limit becomes 1. And then we're going to plug in 17, which is our upper limit. So we're going to get 8 for our upper limit. Okay, and then we are going to antiderive this. So we're going to add 3 over 3, so that'll become u to the 1/3 divided by 1/3, which is the same as multiplying by 3 from 1 to 8. And then we're going to plug in our upper limit minus plug in our lower limit. And you guys remember that the 1/3 power is the same as the cubed root. So this will end up becoming 3 times 2 minus 1. 2 minus 1 is 1. 1 times 3 is 3. Okay, that is the end of this video. Thank you for watching. We will do some more practice in class. Okay, I kept it to 18 minutes.